Okay, let's do one more example problem. Let's do a baseball example problem now. So let's imagine that we've got baseball field and we've got a batter right here. And he swings and hits a ball. Okay, so the ball is initially moving at 36.6 meters per second at an angle of 50 degrees above horizontal. At the moment that he hits the ball, there's an outfielder out here, and the fielder is initially a distance of 110 meters away. And the ball is going to go over his head, and he's going to run this way and catch it. He catches the ball, and the ball is a height h of 0.914 meters above where it was hit. So it was hit at this height here and was caught higher. And so what I want to know is, what velocity does the outfielder have to run in order to catch the ball? Okay, so you think about it and say, well, in order to find the velocity of the outfielder, then we're going to find the average velocity of the outfielder. So the average velocity of the outfielder is going to be the distance that the outfielder has to run divided by the time. So the outfielder has to run some distance d. So all we got to do is find that, and then we're going to know how fast the average velocity the fielder has to run. Okay, so in order to do that, we need to find the total distance x the ball goes. Okay, so x equals x naught plus vx naught t plus 1/2 ax t squared. Okay, and so if the ball is doing this, okay, so the ball is doing this, then v naught is 36.6 meters per second at 50 degrees. So Vx naught is going to be 36.6 meters per second cosine 50 degrees. So Vx naught is going to be equal to 23.5 meters per second. Okay, so that means we know this. We can put our origin right there. So x naught is 0. There's no x acceleration. So x is just going to be vx naught t. All we know is that. Okay. So now, if we can find x, we can subtract the 110 meters that the fielder was originally standing in order to get d. Okay. But we have to find x. And this is not sufficient. Okay. So we have another equation, y equals y naught plus vy naught t plus 1/2 ay t squared. Now again, the ball is doing this. We know the only acceleration is down. So if I put my origin where we start, and I say this way is positive x, and up is positive y, that means that a sub y, the x acceleration, is minus g. Okay. We know v naught, we know the angle, so that means we can find vy naught. Vy naught is going to be v naught sine theta, so vy naught is going to be 36.6 meters per second sine 50 degrees. So vy naught is going to be equal to 28 meters per second. Okay. That's 0. Okay. So y is going to be equal to vy naught t minus 1/2 gt squared. So we know this, we know 1/2, we know g. Well, wait, we also know y. Y is the height at which it's caught. Okay, so that means the only thing we don't know here is going to be t. Okay, so we can rewrite the equation 1/2 gt squared minus vy naught t plus y equals 0. Okay, so that means that t is going to be equal to vy naught plus or minus square root vy naught squared minus 2gy, and then all of that divided by g. Okay, so t is vy naught, so that's going to be 28.0 meter per second plus or minus square root 28 meters per second squared minus 2. Now we're doing meters, so we need to do 9.81 meter per second squared times the 0.914 meters, and then divide by 9.81 meter per second squared. So time is, well, we get two answers, 0.033 seconds and 5.68 seconds. Well, we got two positive numbers. What does this mean? Well, he hit the ball, swung and hit the ball at this height. The ball was caught at this height right here. So we want to find when is it at that height. Well, it's at that height two times. One time here is at t equals 0.033 seconds. 33 milliseconds after the ball was hit, it was that height heading up. It was also at that height over here heading back down at 5.68 seconds. Okay, and so that is the one that we want. Okay, so that means that x, which is vx naught t, is going to be equal to 23.5 meters per second times the 5.68 seconds. Okay, so x turns out to be 133 meters. Now, the fielder was originally standing a distance 110 meters away. Has to go some distance d. So d is going to be 133 meters minus 110 meters. So that means that d is going to be equal to 23 meters. Okay. So the average velocity of the fielder is going to be 23 meters divided by 5.68 seconds, because that's how long it takes the ball to get there. And so the average velocity is going to be 4.0 meters per second. So that's the average speed that the fielder has to run. Okay, so that takes into a time reaction time, takes into a time everything else. It's just that the fielder here, okay, the ball is hit, reaction time speeds up, reaches speed. This entire time, 5.68 seconds, has to go 23 meters. So the average has to be 4 meters per second. Doesn't mean he's running at 4 meters per second the entire time. He's probably running a little faster than that because there's a little bit of reaction time and to begin with. But this is basically what I was after for the problem, is the average time